Welcome to the presentation PCB Design with the KiCad EDA. I'm Altbeer and I'm going to walk you through this presentation. This slide deck is available at altbeer.us/PCB. So what are all these acronyms I just used? KiCad, EDA, PCB. So PCB is a printed circuit board. This is a device that supports electronics. So it is a board that's typically made of non-conductive material that then has copper laminated onto it, and the sheets are etched out to where the copper is only appearing where the program tells it needs to be. And the etching that's done on the copper is done with a form of photolithography, allowing mass duplication of the boards. And it's similar to photographs being produced from a film negative, thus the printing of the circuit boards. Electronic Design Automation is a category of software tools that's used for designing electronic systems, such as integrated circuits and printed circuit boards. And then KiCad, which I have been pronouncing wrong forever as KiCad. This is a specific suite of software that's an EDA used for designing circuit boards. So the term key, I guess, is a reference to a company that the original software author knew. And then CAD stands for computer-aided design. All right, so let's look at the KiCad overview. KiCad, as I explained, is an open source software suite that has the following features. It has a schematic editor that lets you create circuit designs. And this editor comes stocked with a library full of schematic symbols, but it also has a schematic symbol editor. That way you can either modify symbols or create your own. It has a PCB Layout Editor supporting up to 32 copper layers with auto routing options. It also comes stocked with a library of PCB footprints that can be used for putting components on a circuit board or working them into your circuit. And it also has a footprint editor that you can use to modify these footprints or create your own. It also has a 3D viewer, which allows you to inspect your design in an interactive canvas. And it comes stocked with a library of 3D models, but also has options that allow you to easily import additional 3D models as needed to fit them into footprints. These features are all linked together with reference points. So a symbol can call a footprint and a footprint can call a 3D model. That allows for ease of design with quick visual confirmation. So you can download the program and libraries and other documentation at the KiCad website, which is KiCad-PCB.org. So let's talk about the project file layout. So when you launch KiCad for the first time, you're going to create a project to start working. And that's going to create a directory with the project name, and it's going to create some files. And then as you work with various features, it's going to create more files. So I wanted to explain what all these files were, and then also show a recommended directory structure that I use for organizing different files and libraries associated with the project. So whatever you named your project, the files are going to be the project name, and then .pro is going to be the main project file. So this is going to hold all the parameters that apply to the project, like the schematic files and the layout files, etc. A file ending in .sch is a schematic file. A file ending in .KiCad_PCB is the PCB new layout file, and that is the PCB layout program. .net is a netlist file in the PCB new format, and we'll get into what all these mean later. .back is a backup of a schematic file, and KiCad PCB-back is a backup of the layout file. There is a file called -cache.lib, which is a local cache copy of all the symbols used in the schematic. And then there is a -KiCad_WKS. This is for the page layout tool where you can make worksheet templates for how your design files will look in a printed format. There is the fp-lib-table. This is our list of libraries that we're going to use for footprints. And then the sim-lib-table is the list of libraries that we'll reference for schematics. So by default, it's going to use the global libraries here, but if you had added local libraries, these files are going to be updated to show that. Now, some optional directories that I usually put into my projects are a 3D models directory for holding any 3D model files that are not part of the global package that I've added to a project. A Gerber directory for storing the Gerber formatted output files that I'm going to use to send the board to manufacturing. A lib_fp directory for local footprint libraries. So what I usually do with any project that I create is I'll make sure to use a local library for all of the items used in the project, even if those footprints are available in the global libraries. I'll copy them over to a local library. And the reason for that is there's different versions of KiCad, and they're constantly making updates and changes to the library files, adding things, removing things as they move from one version to the next. And if I want my project sitting in GitHub to remain viable after new updates have come out, it has to be able to reference the same exact footprint and schematic files that I've used. So by copying them to a local library, I'm not dependent upon the global libraries to make sure that everything will work a year or 2 years down the road with this project. And then the same thing for the directory lib_sh. This is local libraries for schematic files. And then I usually add a snapshots directory where I'll print off PDF files of the schematics and the PCB layouts and maybe some 3D images of the board. I'll put all those in a snapshots directory. So all those are just optional, but they're recommended because otherwise this directory can get quite full of files and be a little hard to navigate. So setting our project preferences. So when you first launch KiCad with a new project, you're going to want to look at some of the default settings. Specifically, configure paths will have all of the paths on your local system that it's going to search for files. Manage symbol libraries allows you to set which global libraries are going to be available, as well as the location of local project-specific libraries. Manage footprint libraries does the same thing for footprints. It allows you to set global libraries that will be available to the project and location of local libraries. So I want to show you a quick example of what that looks like. So in KiCad, which I've launched here, you would go under Preference, and this is where you would configure paths, and it shows you all the different paths that you have, including your project path. So it has GitHub that it'll pull if it needs libraries from there, but it has your symbol directory, your template directory. These are just the base global libraries. And then under Preferences, Manage Symbol Libraries. So these are, once again, all of the global KiCad symbol libraries, but it's a long list. And when you're trying to place schematics, this can add to a long buffer time when it's first caching all these objects. And if you know, for example, that you're not going to use optical interfaces or telecom interfaces, you can check these off, and then they just won't show up in the list when you're working in KiCad, and it makes searching for components, whether it's schematics or footprints, a lot easier. And then this tab here, project-specific libraries, this is where we're going to call out our project-specific library. And you can see the library path here it uses a variable of that's coming from the configure paths variables, and this is our KiCad project directory. So this PRJ mod variable references whatever directory this has been launched from, that is our project directory. And then you can see I've added lib_sh and then my local library file, 0local. So that's how you would set that, and the same holds true for footprint libraries. It works the same way. So you could set your local footprint libraries. So now let's look at the program layout for KiCad. This is a very intuitive and easy to navigate layout. So you have some major buttons across the top, and then you have your file structure on the left. So the file structure shows the directories I put in there, as well as which files it sees as far as like a schematic file and a layout file. So our first button here, this is called a schema. And this is the Schematic Layout Editor. So when we press that button, it's going to launch that editor. The next button is the Symbol Editor. This is specifically for schematic symbols. And then we have the PCB Layout Editor, which is called PCB New. And then the button next to it is the Footprint Editor. Then we have a Gerber File Viewer, which I think they call GerbView. And a bitmap converter. So the bitmap converter is an interesting program if you want to bring in logos or other graphics for use on like a silk screen layer, or even if you're doing like a copper fill area on your design, and you want to use like an art type program like Adobe Illustrator to actually do the fine artwork for how you want that shape defined, you can then export that as a bitmap and import it here, and it will import it in the footprint format that the PCB Layout Editor will read in as a footprint. PCB and Component Calculator, this is a lot of tools, reference type tools that are useful when you're designing PCBs. So it'll have calculators for based on how much current draw is going to go through a circuit, how wide do the traces need to be, that type of thing. And then we have a page layout editor, and I'm going to be honest, I haven't used this much at all because the default page layouts seem to work for me. But if you're picky about how your printed schematics or your printed PCB layouts look, then you can work with the page layout editor to come up with designs and incorporate logos and whatever else you want into those. That way, when you go to print them out, it will use your settings that are set there. So let's talk about the KiCad design workflow. This is how we're going to actually create a PCB and send it to manufacturing. So we're going to start with a schematic. So we'll open up the schematic editor schema, and we'll build our schematic. So we're going to put symbols down and connect them up with wires or buses, and build the schematic as needed for our circuit. We'll use the symbol editor as we need to either create or modify symbols for our use. And we'll use the calculator as we need to verify component values. And then we're going to associate symbols with footprints. And this is important because while some symbols in the global library already have footprint associations, not all of them do, because there could be multiple footprints that can be used with a single symbol. An example of that might be a specific resistor type where the footprint for the resistor can be very different, but the symbol is just a resistor symbol. So you can have different sizes and shapes of resistors with different footprints that you would have to associate with the resistor symbol that you're using. So you would use the footprint editor if needed to create and modify footprints as you're bringing them in to assign them. And then when you're done with your schematic, you're going to generate a netlist file. And this netlist file is basically looking at all of the wire networks that are part of your schematic design. And it's going to build a table of what connects to what. So if you have a resistor that connects to an LED with a wire, it's going to show the connection points of the resistor and the LED, so it knows that it has to connect these components up in that way. So then we're going to go on to the PCB new file to lay out the PCB. So this program, when we open that up, is going to be blank, and the first thing we're going to want to do is import our netlist file. That way it pulls in from the schematic everything that we want it to have included in the PCB layout. Now it's going to pull in all of those footprints, and the netlist is going to show the interconnections between them, but it's not automatically laying anything out. In fact, most of the components are just going to be jumbled together in the middle of the screen, and you're going to have to drag them away from each other and place them in a manner that you would want on the PCB. And then once you have those all placed, you'll size your board, moving components around. You're going to run traces. You'll add vias if you need to. Do all the things you need to do to actually design the physical aspects of the board using those components. You'll use the calculator as needed to verify the track widths and spacing requirements. And you're going to associate your footprints with 3D models. Now this is optional. Not everyone gets into the 3D viewer or requires its use. I am a big user of the 3D modeling to inspect my work visually. So I would recommend that you just make sure that all of your footprints that you're using have 3D models associated with them. And if not, go ahead and associate models with them, or download the 3D models if needed to associate them. And then you're going to use the 3D viewer to visually inspect your work. Now, once everything's done and you have it the way you like it and it visually looks like it meets your needs, you're going to plot the Gerber files from PCB New. And these are the files that are going to be used in manufacturing. Once you have all your Gerber files printed, then you're going to want to verify that they all look good by opening up the Gerber view. And you can load the files one at a time into Gerber view. Each of the Gerber files represents a single layer of your board. So you'll have like a copper layer as one Gerber file. You'll have the silk screen layer as another. And you'll want to look at all of those to make sure that they look good. And then once you're done, you're going to send those files to manufacturing. So that is the workflow that we use with this program. So let's take a look at the schema, the Schematic Layout Editor. So there's a couple things of note. Your page settings is one of the things you should probably set right away, because changing it later could move things around on the page where you don't want them. And this is where you'll set the actual dimensions of the page, both for a screen view and for the paper layout, whether you're using like an A4 paper or a US letter sized paper for when you're printing this to paper or to PDF. You have a bunch of option toggles here. These are things you can toggle on and off to either change what cursor you're using, or to change how something is working, or to change how you're viewing something. And then across the top, we have several tools that we can use. We have our symbol editor that we can launch that right from here. Same thing with the footprint editor. We have a button that'll allow us to generate a netlist file when we're ready. We have a button that will allow us to check electrical rules to make sure that we didn't leave anything unconnected, or we didn't create a short or something like that in the circuit. And then we also have a button that lets us assign footprints to symbols. And then on the right side here, this long list of tools, these are all tools that we're going to use when working with the schematic. So it starts with the simple select. You can highlight a net, and that would highlight all the things connected between 2 points, all the wires. We could place symbols. We can put in power ports. We can place wires or buses. We can move from a wire to a bus, or from a bus to a bus. We can put a no connection flag in here. And that's important when you're doing electrical checks. If you have a pin on some device that's just not connected and you don't use a no connection flag, it's going to throw a warning that you have an open there. You can put in junctions, use labels to label nets. So like if you have a ground net, you would label it ground, something like that. Now we have global labels, and global labels are different than just the net labels. Global labels are actually used in a schematic to allow us to connect different parts of the schematic together without having to draw lines that are going to crisscross. So we want the schematic to be clean. So if we have, let's say, a 5-volt connection coming off of a microcontroller, and it's got to go to several things, like it goes to an LED or a resistor rather, and it goes to something else, rather than have multiple lines crossing different components and going there, off the microcontroller, we might use a global label that says 5 volt, and then on each of those component pins, we'll put that same global label saying 5 volts. And the schematic editor is going to know this means there's a wire actually connecting these together. And so that's the way you can keep the diagram clean while still producing the same result of network connections. So the next few buttons are related to hierarchical labels, or the hierarchical sheets. So what this is, by default, you're working with one sheet here. Now let's say this one sheet is not enough to take our whole design, and we want to do a second sheet to show the circuits that are on a second layer of our PCB. We can create a second sheet by doing a create hierarchical sheet button, and that's going to put a link on this sheet to that sheet. Now the sheets are not connecting components by default, and that's where we're going to have to use our pins, our hierarchical pins, to pin where in the circuit on this section it's connecting to the circuit on that second page. So this is only really used in larger designs, but it's a useful way to expand a schematic beyond a single page. So instead of having to go to some really large piece of paper that's going to be unprintable in a paper format, you can have multiple pages that detail different parts of the schematic and then link between them. And then the last couple of buttons relate to drawing lines and placing text. And these are lines and text that are not directly related to a component or to the electrical workings of the circuit. This is more just for annotation of our design. And so let's take a look at that in the actual program. So you can see, let me make this bigger. I have my schema editor open, and I'm going to zoom this in a little bit. So I drew a simple circuit here, and you can see the page layout is using an A4 size. Now I can change that by using my page layout here, and I can say instead of A4, I'm going to use US letter size. And it's going to change it to the US letter size dimensions, and all of these things are editable in the page layout. Now for my circuit, I am using components. I'm going to drag one of these. I have my select tool, so I can drag these things around, connect them, and unconnect them as necessary. Now let's say I wanted this to be in a different position. This particular resistor, we can right click and we're going to get a menu. So I can use my orientation to rotate it clockwise or counterclockwise. I can move it around. I can also do this for just like the individual components, the references. I can move those around as needed. So it's very flexible. And then as far as how you tag them together, instead of doing these global labels, I could have just put lines to connect them up by drawing lines between them. So let's say I didn't have this and I didn't have that. I could just take a line and connect these here. And this is a wire. So I use the wire tool and I connect those up. And I could do the same thing on the other side. So, and then just delete that to get rid of something. So I'm going to put it back the way it was. Oops. So you can see the power of this tool, and it's going to allow me to create as many circuits as I need for my printed circuit board and describe what they're doing. I could put text here that that just shows a note of some type. So yeah, it's a very powerful tool. And so I'm going to walk through some of the basics now. So to place a new symbol, the first thing that you're going to want to do is select the Place Symbol tool, and then you're going to click someplace on the schematic page for it to place it. Then you'll be prompted with a choice of symbols. So let me show you how to do that real quick. So we're going to say Place Symbol, and I'll click someplace here. And you can see it's loading all these libraries, and it takes a little while because I have them all selected. And that's where selecting which libraries you're using is important. So let's say I want to put in some audio amplifier. So we'll choose this guy, and we'll put him down here. And that's all there is to placing it. And as long as the Place tool is selected, every time you click on the sheet, you're going to be opted with another object that you could place on there. So let's say I wanted to use some capacitor. We'll put this capacitor right here. Now if you want to get rid of something with the Select tool selected, you can just highlight it, make sure that you have only that thing that you want to delete highlighted, and hit the delete key. All right, so to move and rotate symbols, you would just right-click it, and you would use either the Move or Orientation menus. I already showed you that on the program. To connect symbols, we're going to use the Wire or Bus tool to connect symbols together. To edit a symbol's reference number, we can either double-click on the reference number or use the properties, which gives us all of the references. So let's take a look at how we would do that. So I'm going to choose this resistor again. So if I double click on just where it says R1, you'll see I get the field for R1 up here, and I can change that to R2 or whatever other name I want. Same thing with the axial. I can choose what that is, and the 220 ohm field. So I can choose those individually, or I can highlight or right-click the resistor itself and say Properties, and then Edit Properties, and you'll see all of the values are here. And so I can edit them all. I can determine which ones are visible and which ones are not visible. I can set the text size and how it's centered vertically and horizontally. I can add new fields here by just putting information in there with the plus symbol. Make it visible, and we will see it has test in there. And then if I want to move that field over here or wherever. And you can always get rid of things the same way. If there's something that you don't want to be visible or you just want to delete, it makes it easy to work with symbols in that manner. All right, let's go back. All right, so we talked about how we would add additional information using the plus, and how we would move that around or display it. Now, to place a label, you would click on the global label tool and then click on the schematic, and you'd be prompted to enter a label name and other settings about orientation. I already showed what those look like on the program, so I won't jump back there for this, but this is very powerful. As long as these names match, they're going to be connected in the schematic, and they can be anything that you want. And global labels allow us to clean up our schematic by not crossing wires on it. So the last thing that you want to do is make sure that your symbols have associated footprints by clicking the Assign Footprints button, and make sure that they all have an associated footprint. And then when you're done, you're going to generate a netlist. So let's show you how we would do that. So where it is, there it is, Assign PCB Footprints. So when I click this button, it takes it a minute because it has to load all the footprint libraries. There we go. And so it's showing that I have three components, which I do. I have 1, 2, 3 here. I have my three components, and it looks like two of them had footprints associated before I started, and then this one I added. And you can tell I added it because I highlighted it red. So I did this earlier. But if I wanted to change what that was, I would choose like where I'm looking in what footprint library section, and then I would choose like which footprint I want to use. And once I have a footprint chosen, it'll show up here, and I would hit OK. And then once I have all of my footprints there, you click this button here to generate a netlist, and in PCB new format, you just click the Generate Netlist button, which I've already done in this case. And that's really all there is to the schematic tool. It's easy to use, but it's a very powerful tool. The symbol editor, it works very similar to the schematic tool. It has the same tool sets, but this allows you to modify or create new schematic symbols. And so I'll show you what that looks like real quick, but I'm not going to go into a lot of detail here because it works the same way. So let's say I have a symbol that I want to work with. I double click on it and it pulls it up over here. Now, let's say I don't want to actually edit this symbol. I want to make a copy of it. So I'm going to right click and save a copy, and I'll call this test. And now I'm working with my test copy here. And let's say with this test copy, I want to change a different property. I can change the text on one of these. I can change the inputs on one of these. I can even just have the schematic be exactly the same and just change which footprint it's associated to by default by setting the properties of this. We can tell it a value, the data sheet, the footprint that is the default. Now these can be overridden when you're using the schematic symbols in a schematic layout, but it's nice to have defaults for them. That way it lessens your work in assigning footprints. So an advantage to this method is, let's say you have a symbol for a resistor, but you want to have 4 or 5 different footprints associated with that resistor. You can actually make 5 different schematic symbols for resistor, even though they're going to be exactly the same from the schematic point of view. Each one is going to reference a different footprint, and that'll make it easier to work with on the schematic. And when you're done, you can hit Control S to save it, or you can just click Save, and then you close it. So that's the schematic symbol editor. So PCB New is our PCB Layout Editor. And this program is where we're actually going to take the components and run traces between them and work with designing our circuit board. So the first thing that you might want to do is work with the board setup. This will set your defaults that you're going to be working with. At any point, if you want to change your track and via and grid settings, there are drop downs provided on this row that allow for that. And then just like the other tool, there's a lot of options that can be toggled on and off to do things a certain way or to view things a certain way. Across the top here, we have a button that allows us to open a footprint editor. We also have a button that lets us load the net list. And then this drop down is how we're going to choose our working layer, because we're going to work on one layer at a time as we like draw traces on a copper layer or add silk to a silk screen layer. And then the layers that are visible, it's going to show them all here, but this column on the right-hand side is showing all of our visible layers as check marks, so we can check things off if it gets too busy and we just want to look at certain layers at a time. And then this row here of tools, just like the other program, these are all the different tools that we will use when working with this program, such as placing footprints or routing tracks or adding vias, adding filled zones, graphic lines, etc. So this is how we'll actually make our PCB. So let's look at some of the basics. So the first thing that we're going to do is load a netlist file. And when we load a netlist file, it's going to add the footprints for all the components. You can update an existing PCB with a new netlist load, but it's going to move things around and you're probably going to have to update all the traces when you do that. So it's important to try to get your schematic finalized before you start moving into the PCB layout. So once it loads all the footprints, they're all going to be kind of jumbled together like is shown in this picture. And then you're going to have to move them where you want them to be. And then you're going to use the select tool and the property settings to move and orient them on the board the way you want them. Once you get them in the places that you want them, you're going to select one of the copper layers as the active layer, and then you're going to click on the Route Tracks button to run traces between the different footprint connections. To add silk screen text to the board, you would select which silk screen layer that you're going to work on, the front or the back, as the active layer. And then you'll click the Add Text button, and you can type text that will appear on the board then. And then to size your PCB, we have to give it an outline in the edge cuts layer. So we're going to select edge cuts, and then we'll use the graphic lines to draw a box or a rectangle around our components. And this will be the outer edges of the board. Now we can also use the edge cuts layer to define cutouts in the PCB. So you can see in my example here, I defined a little square cutout there. And you can use the 3D viewer at any point during the design to view and see how your board is progressing. It gives you a visual view that you can rotate around, and I'll show you that in a minute. When you're all done, then we're going to generate the Gerber files. So let's take a look at the PCB program, PCB New. And I already have an example loaded here. So once it opens up, it will show my example file. So I'm going to make this a little smaller. So as I showed earlier, we have all of these visible layers. So let's say and I can zoom in and out as well as needed. But let's say we didn't want to see the edge cuts layer. we can just turn it off. Or let's say we didn't want to see the silk layer. So we can turn those on and off to make it easier to view what is actually being displayed on the board as we're working with things. If we wanted to run traces, we would make sure using this drop down that we're working on either the front or the back copper. So I'm going to choose back copper, and I'm going to choose my route tracks. Now let's say I wanted to route a track. You can see it's warning me if I try to go over the edge of the board or through my cutout. And I'll route it this way, and we'll take a long way around here. And you can see when I go to connect it to this pin, it's removing my track on the upper layer of the board. So this is working with rules that's saying we are already connected here, so I'm going to remove this one. He decided he wants to put it on the back of the board instead. Now I can leave it like that. Hitting escape gets rid of the auto place function and will stop, and I can always come back to it later and connect to it by using this tool. And then Control Z can be used to undo. So it's very easy to work with, and it makes routing things and placing components on boards very easy. So let's now look at what that 3D viewer looks like. So if I go to View, 3D Viewer, once again make it a little smaller because I don't want my face to block it. So we can see our PCB view, it starts in a top-down format. Now I can use these tools here to modify the view, or I can just click and drag and I can view what it looks like on the front of the board, on the back of the board, all the components. I can zoom in and zoom out. It really gives you a good understanding of what the board is going to look like with components on it. But more than that, I can turn the components off and see what it looks like without the components on it. So if I go to Preferences, where is it? Display Options. So here's where I can tell it not to show my models by clicking those off. And now we can see I have just what the actual PCB is going to look like when I get it. It doesn't have any of the components on there. So you can show it with the components on the board, with the components off the board, and get a good idea of what your board would look like. All right, that was PCB New. Now we have a footprint editor. This works just like the PCB New Layout Editor, but you're only working with one component. And this is where you can make changes or create new component layouts based on your needs. You can also associate default 3D models here, or you can leave it blank if it's a footprint that can have multiple type of 3D models, and then you would have to choose the 3D model associations later. So the Gerber file viewer, this is where we would just open up the Gerber file and make sure that once we've plotted that Gerber file, it looks fine. And actually, that was one thing that I didn't do in PCB New was generate a Gerber file. So let's do that real quick, and then we'll open it up in the Gerber file viewer. So in our PCB New, to make a Gerber file, we're going to hit this plot button. And you can see where it says Gerber format is one of the formats. So it has multiple formats you can choose from. I'm choosing the Gerber format, and I'm going to choose my output directory as that Gerber directory that I set. And I'm going to hit plot, and you can see based on the messages here, it created a file for every one of my layers that I had selected. Now, because most of the manufacturers that I work with require drill files as well, I'm going to click the drill file and click Generate Drill File, and it created two files. Now, one thing to note is there's a lot of different options that you can select, whether it's for the Gerber file or for the drill file. The PCB manufacturer that you're going to be working with will have specifications on their site that tells you what settings they're looking for here. And in fact, PCBWay and JLPCB, they both specifically tell you the KiCad settings or KiCad in KiCad what settings to set for them to be able to work with the board. They may be able to work with it fine if you set it in another way, but to make sure that they're not going to have any issues working with your Gerber files, it's always best to look at their recommendations first and then generate the file based on how they want it. Now, for those two manufacturers, I actually made myself a little quick reference of those settings. So I have for JLPCB what the I took an image of what the Gerber file settings are, and then for PCBWay the same thing, and I have the drill file settings. So for both of these I know exactly how to set them for the manufacturer. I could have took it as a note, but I figured just a screenshot was easier. And whatever manufacturer you decide to work with, you're going to want to take note of that and then make sure that you're generating the files in the way that they can easiest work with them. So let's look at our Gerber file viewer now. So the Gerber file viewer lets us open different Gerber files, and we can use this to open files that other people created with other projects too. It doesn't have to be our own generated files. And so let's look at our front copper. And we can see it loaded the front copper, but only the front copper. Now let's say I want to open another Gerber file to layer on top of this one, and I'm going to choose my front silk. So now it has both, and I can choose which one I'm looking at. So you can open up all the files in this manner and make sure that everything looks exactly the way it should. There's no errors in file generation that could cause you problems later. All right, Bitmap to Component Viewer. This is a pretty simple tool, but it's a powerful one. It'll let you load a bitmap image in several formats. It takes like JPEG and PNG and a bunch of different formats. And then you can look at how that image looks either as the original picture or grayscale or black and white. Since silk screen is a single color layer, I usually go to black and white here. And then we'll set the size. This is how it will be sized when we place it on the PCB. And we can load it as either a .lib file, which is used as schematics. So in that case, you might want a colorful picture that's going to be used in the schematic file. We can load it as a PCB new file. This is the actual footprint file, so that it'll become a footprint that we can then load into PCB new. And with the footprint selected, we can choose whether it's a silk screen layer or a solder mask or a user defined layer that we can change later to be whatever layer we want it to be. So for example, if we were going to just load a shape here that is going to be used for a copper fill area, I would probably choose to start it as an eco layer, a eco 1. And then once I loaded the footprint, I can change which layer it's on within PCB new, and I can tell it that, no, this is going to be on front copper now. So very powerful tool. PCB calculator. This is a handy little tool. You can look up resistor values or the width that traces need to be based on current draw. It has several tools in here that are very useful. And our page layout editor, which will allow you to change the default page layout that's presented when you print. And now we come to PCB manufacturing. So once you've completed your design and you created the Gerber files and the drill files, you have a choice of where you're going to send it to be manufactured. So the PCBshopper.com site is kind of like a Travelocity site for PCB manufacturers. It shows a whole bunch of them on there and gives you lots of options. And then we have some others that I've used here, JLC PCB, PCBWay, Osh Park. These are all known good manufacturers with each of them have different trade-offs. So when you're choosing a manufacturer, you have to look at those trade-offs. So cost may be your top factor, and in that case, you're going to go for the cheapest. Like JLC PCB is very inexpensive, but it has some pretty severe limitations, such as they only do white silkscreen. If you need silkscreen in a different color, too bad. They only do white. They only have a certain range of colors that they can use for their solder masks. They only have certain PCB material types. The next inexpensive is probably PCB Way. They have a lot more options for those colors that I was talking about. They're still inexpensive. They have fast shipping. But if you really want a detailed, beautiful, high-quality board and you're worried about shipping coming from overseas, maybe you're looking for something made in the USA, then you might look at something like Osh Park. So there's a lot of trade-offs there, and you have to make the choice on which is the best manufacturer for you. Look at customer reviews, see which one is going to meet your needs, and then you're going to send it to the manufacturer, usually through a web interface. So I have PCB Ways shown here, or here's JLC PCB. You can get instant quotes from either. It's going to have you upload the Gerber file as a zip file. So you'll want to make sure that when you're working with these Gerber files, you see how it created all these different files. We'll want to zip them up into a single zip file that we then upload into their website. And then it'll do some analysis on there. And it'll give you a quote and tell you how much will it cost to run how many of these boards. You might do a prototype run of 5 or 10 boards just to make sure it's going to work okay. And then proceed to a larger run of a few hundred boards based on your need. But both of these sites work really well, and so does Osh Park. So that's 3 examples that I've personally used before, but PCB Shopper is another good site to find new sites out there that might be options for you. And with that, we come to the end of my presentation. I hope you enjoyed this. I hope you learned something from it. If you need the slide deck, it's under altbeer.us/PCB. And I have code listed here, but really this is just like the presentation files are listed here as well. So you can find the presentations there. So thank you for attending, and I hope you have a great BSidesDFW Con.